Hi, I'm Nandini Pasumarthy from the Happy Research Lab at RMIT University, Victoria, Australia. I'm happy to present the paper Gooey Gut Trail, Board Game Play to Understand Human-Microbial Interactions. I present this on behalf of my colleagues Rakesh Patibanda, Ling, Elise Hoven, Jessica Danaher, and Rohit Ashok Khot from RMIT, Monash University, and University of Technology, Sydney. This project is part of a PhD research on understanding the design of interactive experiences to engage with gut health factors. Our gastrointestinal system, or the gut, consists of a trillion microscopic beings known as the gut microbiome. Our microbiome influences our gut health through a complex set of interactions involving multiple external factors such as mode of birth, early microbial exposure, genetics, antibiotics, and diet, to name a few. A wider understanding of these factors is vital to help make gut-friendly decisions in everyday life. However, its complexity can challenge public understanding if not approached systematically. Existing technologies concerning gut health are corrective in nature with focus on behavior change and disease prevention. Games on the topic of microbiome focus more on the scientific names and characteristics of bacteria that may not be useful for the general population. Moreover, most of these tools cover gut health through a singular lens, such as diet or physical activity, thus isolating other important aspects that influence our gut health. Overall, there are fewer interactive tools available for engagement with this topic. To address this, we designed a board game called Gooey Gut Trail to engage players in the multifactorial interactions that influence gut microbial diversity. Through the enactment of in-game activities, players learn how their habits surrounding diet, physical activity, emotions, lifestyle influence the gut microbial population. The game involves the following components. Players play the game with a set of two meeples, namely the warrior and the minion, that represent friendly and unfriendly gut bacteria population. A persona card that contains a set of attributes and individual winning conditions that influence the gameplay. A game board involving a numbered trail with two start positions and two end positions, one for each of the meeple. The friendly bacteria starts the game at the lower end of the number trail and ascends towards position 85 by the end of the game. The unfriendly bacteria starts the game at the higher end of the number trail and descends down to 15, together achieving a balance of 85 is to 15, a winning ratio of friendly and unfriendly bacteria. The card decks, namely the individual, community, and food, influences the movement of these two meeples across the game board. The first player to accomplish their winning conditions and move their meeples across to the finish points wins the game. We used research through design methodology, the MDA framework, and a deck of lenses to design the board game. We invite you to read our pictorial for a detailed account of the design process. We conducted a qualitative study with 15 participants involving semi-structured interviews and observations from video recordings of the playtest sessions to gather user experience and player insights. We thematically analyzed the data, which led to 3 themes and 12 findings. Findings: interaction with game scenarios enabled reflection on real-life activities. For example, participants reflected on how the game added a new lens, the lens of the gut microbiome, through which they now view their everyday activities. Meeple movement led to playful visualization of human microbial interactions. Players reported that visual representation helped to bring microbes from their background presence to the forefront of the player experience, thus making it relatable for them. Chance and choice mechanics led to contemplation on real-life agency over aspects that influence gut health. Some players recognize the agency they have in real life to take charge over actions and habits that influence their gut health, which was in contrast to the randomness of some events generated in the game, where they had no control. This led to feelings of motivation to take gut-friendly action in some participants. Based on our study findings, we suggest 6 design strategies for playful engagement with gut health. Use the mechanic of choice along with chance to increase perceived player agency. The game uses choice and chance mechanics to balance the level of agency and randomness generated by the game, thus allowing the player to feel relatively in control over the game outcome. Use salutogenic framing of health concepts to motivate action. Using prescriptive language and message framing in the game by highlighting health-promoting aspects over disease-causing aspects led players to self-report on feelings of motivation and readiness to take positive action. Deliberately slow down game pace to create opportunities for sustained engagement. While introducing multiple insights for players to interact with, it can often be overwhelming if the game is competitive as well as fast. Deliberately slowing down the pace of the game through movement-based mechanics or by introducing pleasurable challenges that slow down the game for most players can allow players to engage with insights more freely and sustain their attention. We hope that our research inspires playful exploration towards understanding human microbial interactions. We thank you for your time and invite you to read our full paper for more details. Thank you.